Hello, this is Mrs. Pullen for Algebra 2, Lesson 8.01 on Basic Graphing, and in this video I'll be going over a couple of examples from tonight's practice. So in the first problem, we're asked to graph y equals sine of 3 sine of x. And so everything is really based on the unit circle, and what we're doing is we're unraveling that unit circle. So in a unit circle, this is 0 degrees, 90. Again, we're using radians when we unwrap the unit circle. This is pi is 180, 3 pi over 2 is 270, and 2 pi is the same thing as 360. And what we're doing is we're literally going to be unwrapping the unit circle. And I'm not quite sure if that was clear in today's lesson, so I just wanted to clarify. That's a -1. Let's make that a little more clear. -1, 0, and this is 0, -1. So if I'm looking to graph 3 sine of x, okay, sine is the y coordinate. So typically, if I was just graphing y equal sine of x, we would just pull off the y coordinate, and let me just highlight, from the unit circle, and we're literally unwinding the unit circle onto the graph. So we're going to graph 0, 0. At pi over 2, it's going to be 1. At pi, it's going to be back at 0. At 3 pi over 2, it's going to be -1. And at 2 pi at 360, we're back to 0. So if I'm just graphing from, whoop, I missed it, from 0 to 2 pi, that's what one cycle of the sine graph would look like. But if I'm going from -2 pi to 2 pi, we actually have to graph backwards. We're actually going backwards. So then what we would be doing is this would be 0, 0, but then we would be graphing -pi over 2. Well, if you're rotating 90 degrees to the right, that's the same thing as 3 pi over 2, and so that would equal to -1. And if we're unwrapping to -pi, that's the same thing as pi, so the y-coordinate there is 0. And at 3 pi over 2, we're back to 1. And at 360, so that's a full rotation clockwise to the left, we're back at 2 pi, which is 0. And so now we make this nice smooth curve. And notice with the sine curve, one cycle is you're starting at the midline or the baseline. You're going to the maximum. You're going back to the midline. Then you're going minimum, and then you're going 1. So the pattern is 0, 1, 0, -1, 0. When we have a number in front of the function, it's called the amplitude, and it actually multiplies what I call these critical values by 3. So this would then be 0 times 3 is 0, 1 times 3 is 3, 0 times 3 is back to 0, -1 times 3 is -3, and 0 times 3 is back to 0. So we would be graphing 0, 3, 0, -1, -3 back to 0. And that's one cycle. Now, you don't have to graph the original sine function. I was just doing it to help you understand the concept better. You could have graphed right away the other function. Now we're going backwards. So At negative pi over 2, instead of it being negative 1, it's negative 3. At negative pi, instead of it being, it would still be 0. At negative 3 pi over 2, it would be 1 times 3 or 3, and then you would be back to 0. And so that's that second cycle. Again, the amplitude is defined as the distance from the maximum value to the baseline, in this case the x-axis, or the minimum value to the baseline, which is the x-axis, and that's the amplitude of the graph. And the range of the function is going from the minimum y to the maximum y. So in function notation, it would be negative 3 is less than or equal to y is less than or equal to 3. But in interval notation, it would be negative 3 to 3. Okay, so now let's go to for cosine of x. In this case, I'm not going to graph the original cosine function just so you can see how it works. I would always recommend graphing a unit circle somewhere on your paper because everything is based on these quadrantal angles and it will help guide you. So this is 0, pi over 2, pi, 3 pi over 2 back to 2 pi. And this point over here is 1, 0. This point is 0, negative 1. This point is 0, pardon me, that's not correct. This is negative 1, 0, and this is 0, negative 1, and then you're back to 1, 0. So normally cosine would be 1, 0, negative 1, 0, 1. That would be the pattern. But notice we have an amplitude, a multiplier of 4, the number preceding that function. It's always going to be an absolute value. So even if this was negative, the amplitude would still be positive. The negative would just tell you to reflect the curve over the x-axis. So the general pattern for cosine, if you're starting at a reference point of 0 degrees, is going to be max, the baseline or middle. It's actually called the midline, you'll see. The minimum value, the midline, back to the maximum. So in our case, the maximum value of the function is going to be 4. So max is going to be the positive of the amplitude, and the minimum value is going to be the negative of that amplitude, negative 4. So you're actually graphing 4, 0, negative 4, 0, 4. That's the pattern you're going to use. So at 0 degrees, and again, remember, I always want you to start at 0, and you'll see why, especially tomorrow. So that's 0, 4, and then it's going to be pi over 2, 0, then negative 4, 0. Then the next point in the pattern is back to 0 at 3 pi over 2, and then you're back to 2. If it's easier, just graph one of the cycles first. And now you're going to go backwards, right? So if we want to go to negative pi over 2, typically, it's going to be 0, even though the amplitude's 4, because 0 times 4 is 0. And then at negative pi, you're back to negative 1, but that's actually negative 4 because of that amplitude. Then you're back at negative 3 pi over 2, back to 0. Notice it's always going through 0 before it hits the max or mean point. And then you're going back to 4 at negative 2 pi, and you're going to make that nice smooth graph. So what if you have a negative in front of the amplitude? Okay, first of all, I'm going to emphasize this constantly. The amplitude is always positive. You always take the absolute value of it. So typically, the pattern would be 1, 0, negative 1, 0, 1. Or max, mid, the midline, minimum value, midline, maximum value. That, again, is from the unit circle that we see above. 1, 0, negative 1, 0, 1 for cosine. When we unwrap it onto an x-axis. Remember, these were taking this unit circle and literally placing it on these angles on the x-axis, and were the output of that function are these y values, those coordinates. So the amplitude is 3, so normally we would just go 3, 0, negative 3, 0, 3. But because there's a negative in front of it, that tells us to reflect the graph over the x-axis. So what it's going to look like is you're flipping everything. So this is the minimum, well, you're negating everything. So this would be negative 3, this would be 0, this is 3, this is 0, and this is negative 3. So in actuality, you're graphing the minimum value, then the midline, the maximum value, then the midline, and back to the minimum value. So let's graph that. So it's going to be negative 3, 0, 3, 0, negative 3. And again, make sure it's a curved shape. It shouldn't look like a V. It should be nice and smooth. It shouldn't even have that there. Okay. And now let's go to the other side. So typically at negative pi over 2, it's going to be 0. Then it's going to be back to the maximum value, back to 0, and back to the minimum. So it's minimum, midline, maximum, midline, minimum. Midline, maximum, midline, back to minimum. And again, that's when you have a negative in front, which actually reflects the graph over the x-axis. Okay, I'm not going to go through all these problems, but I did want to go over like a problem like 7, and then I'll go back to a problem like 6. So on number 7, you're told that an angle increases from pi to 2 pi radians. As the angle increases from pi to 2 pi radians, what happens to the cosine of the angle? Okay, so let's graph one cycle of that function. It's really helpful to see that. Just trying to get that up a bit. I'm only going to graph one cycle. So 90 degrees, 180 degrees, 270 degrees, 360 degrees. Again, pi over 2 pi, 3 pi over 2, and 2 pi. And I'm just going to graph a basic cosine function. So the basic cosine function is 1, 0, negative 1, 0, 1. Again, max, midline, minimum value, midline, maximum value. So what will that function look like? It is going to look like 1, 0, negative 1, 0, 1. By the way, there are other ways of doing it, but this is visually helpful to many people. So what's happening to the function cosine between pi over 2 and pi? Well, notice as you're going to the right, it's going uphill. That means within the interval from pi to 2 pi, because that's what they're asking for specifically, they're only looking at this area. We notice that the function is increasing throughout. And so the answer to this problem is increasing throughout the interval. I'm going to do problem number 9, and then, I'm sorry, number 8, and then I'll go back to 6, and I'll let you do the rest. Again, with these kind of problems, it's helpful to draw a quick graph of this function to see what it looks like. And so you're graphing pi over 2, pi, 3 pi over 2, and 2 pi. Again, you're taking the angles from the quadrantal angles and laying them on the x-axis. And again, I'm just using an amplitude of 1. And I'm going to graph one cycle. So for cosine, it's when you unwrap the unit circle, it's 0, 1, 0, 1, 0. Oh, let me erase. 0, 1, 0, negative 1, 0, or midline, maximum, midline, minimum, midline. So it's midline, maximum, midline, minimum, midline. So the function's going to look like that. So what's happening from 0 to pi? I think I need the highlighter. So what's happening is from 0 to pi over 2, you're increasing, and then from pi over 2 to pi, you're decreasing. So it's increasing and then decreasing as you go to the right. Okay. And let's go back to number 6. Which of the following lines, when drawn, would not intersect the graph of y equals 6 sine of x? Okay. So again, you may be able to just visually see it. And there are a couple of ways of doing it, but one way of doing it again is just to do a quick sketch. In this case, the amplitude is 6, not 1. So normally you would do 0, 1, 0, negative 1, 0, 1 for, negative 1, 0 for sine. But instead, since the amplitude is 6, this 1 becomes a 6, and the negative 1 becomes a negative 6. And so the function would look something like this. 0, make this 6 and this negative 6. 0, 6, 0, negative 6, 0. And you would sketch out that sine function. But now it's saying which would not intersect. Well, x is equal to 8. If I went ahead and draw it, well, pi is, x equals something is a vertical line. And 2 pi is a little over 6 because pi is 3.14. 2 times that, that's a little over 6. So that would be a line here. And eventually this curve would definitely intersect that graph. It would continue out and you would see, I'll just make it in red, you would see it eventually intersect. So that's certainly not our answer. X is equal to 3 is just that same vertical line, and it would be a little to the left of pi because pi is 3. So that doesn't seem to be the answer. And again, x is equal to something is a vertical line. Let me see if I can get this line out of the way now that I have it. Let's move it out of the way. Actually, we can make it, can I make it horizontal? I'll just draw another line. Okay, so we know that those two are in the answer. y equals -4 is a horizontal line that's above -6. Well, that's intersecting, so that's not working. But y equals 9 is a horizontal line, and it's going to be, I don't know why this line is not listening. I'm just going to draw another line. Please be okay with that. So y equals 9 is just this line, and it's going totally above. And since the maximum value of this function is that positive the amplitude of 6, it's not intersecting that line y equals 9. And so that's why this is the answer. I hope this video was helpful, and I look forward to seeing you tomorrow.